Good morning. Good morning to all of you, students. Am I audible?
Good Good morning, sir.
Morning. In the previous lecture, we talked about pump hydro storage system, and we have to see the advantages and disadvantages of pump hydro storage system. What are the advantages of pump hydro storage system? It is mature and reliable technology by which we can get a reliable source or reliable energy, and it has high overall efficiency. Its efficiency is never about 70 to 80%, and it will respond fast. And in disadvantages, what are the disadvantages of pump hydro storage? It has limited potential sites, need for a high altitude reservoir, and environmental factors. That means in pump hydro storage we need two reservoir. One is high level, another is low level. This high level and low level reservoir are not present in flat area, so the requirement of these two reservoir should be in hilly area. So we need hilly area. So this is a limitation, and another is environment factor. Suppose we make a dam on some reservoir and we control the flow of water, so it may affect the environment. So these are the disadvantages of hydro storage. Now we move to our next topic: compressed air energy storage. Ritesh Kumar, can you tell me why we use energy storage system? Ritesh Kumar,
Yes, sir.
can you tell me why we use energy storage system?
To store electricity, sir.
To store electrical energy, and
Yes, sir.
and we have to supply that electrical energy on peak demand. So here we used compressed air energy storage system. What we do in this topology? Just let me draw. This is our art. This is a reserve. We are taking the normal air and by a compressor we compress the air, then we push this air in a canal or abandoned mine. Though the abandoned mines are empty, so we can push their air, and the compressed air is store the energy. Have you got my point? It is.
Yes, sir. Here we store air.
Yeah, by using a
Yes.
compressor, we compress the air and store in the reservoir. The reservoir are maybe salt cave or say abandoned mines. There is this free space. Is there any free
Sir,
space of
underground.
PET or abandoned mine? Is there empty space in abandoned mine? It is.
Yes, sir.
So we can store there, compress air, and when we do that, when the upload or off peak period is there, so we do that, and after that, when the peak demand is coming, we take this compressed air and using a turbine generator, we produced electricity. In the when the peak demand is coming, then at that time we take that compressed air. This is reservoir. We take the compressed air, and by the compressed air we rotate a turbine and generator set. By this we generate the electricity and supply the peak demand. I hope you understand the topology or working principle, how the compressed air energy storage are working. Deepak, is it clear to you now?
Yes, sir.
Okay. Now we see the diagram. This is a salt dam, or you can say this is a salt cavern. In salt uh, cavern, we push first water and take out the salty water, so that it creates a empty space where we used, or that empty space we can use a reservoir. We take the normal air by a compressor we push there the air or compressed air. Then when we do that, Deepak, when we do that,
During peak demand.
at the time of peak, at the
Yes,
time
sir.
of peak or peak demand,
Optic demand, sir.
of peak demand. Okay. And we are taking that compressed air and by the turbine generator set, we generate the electricity and supply the peak demand. There are two types of basically compressed air system is adopted. One is called adiabatic, another is called diabatic. You can see the next diagram. This is also the previous diagram, but there is a difference between this diagram in case of heat exchanger. You can see the previous diagram, the heat exchanger is belongs to the only turbine and generator set. But in case of here, you can see the heat exchanger is between compressor and the turbine generator set. This type heat exchanger can be recuperator type, and this should be regenerative type, because here, because in this case the heat exchange is at the same time when the compressed air are going to the high pressure turbine, and the excess air or the exhaust air is going through that, and this heat is extract and reheat the compressed air. But in this case, we can see when the air is compressed, the heat is going up or rise up. We take that heat and store on heat exchanger, and when the peak demand is coming and the compressed air is taken out, then we have to heat the compressed air at that time, because uh, we do not heat the compressed air, the efficiency will fall. And in this case, not only we heat the compressed air, we mix also natural gas with this compressed air, and then we burn that so that the pressure will move and the turbine will generate the mechanical power so that the electricity will produce sufficient. Have you got my point, Deepak, Ritesh?
Yes, sir. Yes, sir.
Pooja, can you tell me what is the working principle of compressed air energy storage system? Pooja Sharma, just explain the working process of compressed air energy storage system. How we do that? Pooja Sharma, can you explain? Just explain what is the process or what is the going on in compressed air energy storage system. Avinash, can you explain it?
Yes, sir.
So please
Sir,
explain.
in compress storage system, at the time of peak load, we store air using a compressor, and when peak demand is coming, we use compressed air
Hmm.
and generate electricity using turbine generator.
Good. So this is the working principle or how the compressed air energy storage system works. Then we goes to the types of compressed air energy storage system. We said previously that there is two types of storage system, compressed air storage system. One is called adiabatic, another is called diabatic. In adiabatic, there is no heat loss at the time of that process or the total process. So we can say that heat from the compression is captured and stored in solid or liquid, so that the heat is not lost, and heat is reincorporated during the release, so there is no heat loss, and the efficiency of that adiabatic system is nearly 100%. And in case of diabetic storage system, the heat is lost through the cooling, because in storage system, though it is in underground and though it is suppose a abandoned mine, and the surface of that abandoned mine absorbs some heat, so that when we get or when we extract the compressed air, oh, we did not get the temperature, so we have to rise the temperature of that compressed air. So we have to burn some natural gas with this compressed air, so that we can rise the temperature of that compressed air. So we have to use some natural gas and mix with compressed air, and we have to burn that, so we can get the pressure and corresponding heat. So with respect to adiabatic storage system, we can say that this is inefficient than adiabatic system, and in diabetic system, with a huge the half of the gas storage, we store how much the gas, and we can use half of the compressed air. And we now goes to the pros and cons of compressed air electricity storage, sorry, compressed air energy storage. The efficiency of the compressed air energy storage is near about 70 to 80%. That is high as like pump hydro storage, and it has also high storage capacity, because the abandoned mine are in big size, so we can store in a huge energy or high volume of compressed air. Though the high volume of the compressed air, uh, so we can say that it is a high storage capacity. And previously I said that the efficiency of the system is overall 70 to 80%, and it also fast response, because when we need or when the peak demand is come, At that time, we can easily or uh, instantaneously we can generate the electricity. So by using turbine generator system, so we can say that this is a fast response system, and this is also a inexpensive energy storage system because we don't have much expenditure on that to create that system, because the main part of that is reservoir, which is we get naturally. So we can say that this is less expensive system. And the disadvantages are we require large storage or large reservoir, because if we make it small, so we cannot supply the energy or electric energy for long time. So to provide the energy or say electric energy in the time of peak demand, we require large storage or large reservoir. And we say there are two types of energy storage: compressed air energy storage, adiabatic and diabatic. And we get diabatic storage, but the efficiency of the diabatic storage is less. But we need adiabatic system, but in nature we did not get too much adiabatic system, because the caverns or the abandoned mines are absorbing the heat when we store the compressed air. So we can say the storage are limited of our adiabatic system. These are the disadvantages of compressed air energy storage system. Now we goes to the installation. Though there is no installation in India, we have to take example of foreign countries. First, in Germany, Handrop in Handrop, the first compressed air energy storage plant is commissioned, and the reservoir are two mined salt cavern. Uh, Actually, there is two salt cavern by which we store the compressed air, and we storage for 8 hour at the rate of 60 megawatt. And if we can generate by that storage the electricity of 290 megawatt for 2 hour. Though it is in 1978, so the electricity is not give for too long time. But after that, the second storage is say in Alabama, which is situated in 1991, and the capacity is 110. So this is the second which we situated or installed. And third one in 2012, which is in Texas, and its capacity is 500 megawatt. And the first advanced adiabatic compressed air is constructed in Germany in 2013, by which we can increase the efficiency of compressed air energy storage system. So these are the basically example. Actually, there are four compressed air energy storage system are situated because uh, the efficiency or the you can say the adiabatic mines are not, though there is present at the time, so we did not use too much of compressed air energy storage system. We prefer mainly pump hydro. Now Priti Kumari, are you there? Priti Kumari, Priti Kumari, are you there? Am I audible?
Yes, sir.
Priti Kumari, are you there? Rahul, Rahul, can you explain
Yes,
the
sir.
working principle of compressed air energy storage system?
Yes, sir. During the low demand, we store compressed air in uh, abandoned mines, and then we use that compressed air to supply the peak demand.
And how many types of compressed air energy storage system available? How
Yes,
many
sir.
types?
Sir, repeat the question.
How many types of compressed air energy storage system are there?
Sir, two types.
Two types. What are these?
Uh, so adiabatic and
Adiabatic
di-
and diabetic. Which efficiency is more?
so adiabatic.
Adiabatic. Why?
As in that case, the heat loss is minimum.
The heat loss is
Uh,
minimum. Good.
so we
Good. Good.
yes, sir.
Good. Then, though the heat
So
loss is though the
we
heat
don't
loss
need
is
to
called.
again heat that compressed air for utilizing it.
Okay. So the efficiency. That's why the efficiency of adiabatic system is higher than
High
diabetic.
diabetic.
Okay. And what kind of heat exchanger used here? There, I show you in diagram. There are two types of heat exchanger are there. Have you seen that?
Heat yes, sir. Uh,
See, see on the diagram. This heat exchanger is called recuperator type, and that one is called regenerator type.
okay, sir. Yes, sir.
Now tell me, what kind of heat exchanger are used in compressed air energy system? Or how many types of heat exchanger are used for compressed air
So
energy storage system?
Two types.
Two types. One is called recuperator type, another is called regenerator type.
Uh, Regenerator type. Yes.
And what is the function of recuperator type, or how the recuperator type heat exchanger are working? Can you tell me that? And the recuperator type heat exchanger work basically at the same time. That means it take heat from the exhaust or waste air and heat the compressed air. This function is happening simultaneously or at a time, you can say. But in case of regenerative type, the heat is taking when the compressed air is pushed on the reservoir, and that heat is used to heat up the compressed air when the peak demand is coming, and we are taking, or we can say, we are using the compressed air when we produce the electricity. At that time we heated up the compressed air. So in regenerative type heat exchanger, the heat exchange is not at the same time, but recuperator type, the heat exchange in happen in same time. Have you
Yes,
understand
sir.
that?
Yes, sir.
Okay. And in modern days, what happened there, we use two turbine, because to increase the efficiency we use two turbine. Suppose what we do, actually when we take the compressed air, first we push that, or we insert that compressed air in the high pressure turbine. First work, or first mechanical convert that pressure to in mechanical energy, and by this turbine we rotate a shaft, and after that the heat is, or pressure is less on that compressed air. So we have to reheat, or you can say, uh, we have to increase the efficiency, we have to reheat that compressed air. So what we do, we by the using of natural gas, we burn that natural gas and uh, heated up that compressed air and also increase the pressure. Then we insert that compressed air on low pressure turbine, and after that the exhaust, or uh, X is the air which are going through the exhaust, and we take the temperature also and reheat the compressed air. To increase the efficiency of the system, we use here to two turbine. One is high pressure and another is low pressure. In case of compressor also you can use, there are two compressor. By using you can increase the system efficiency. In thermal power plant also, we first preheat the water, and you can say steam also. We have to, how much we have to produce heat or insert heat, the efficiency of the system will increase automatically. That means if we make it in a step by step, by that we can increase the efficiency of the system. And which type of compressed air energy system is actually we prefer? Avinash, can you tell me? Which kind of compressed air energy storage system we prefer? Adiabatic or diabatic?
Sir, adiabatic system.
Adiabatic. Is there any availability of adiabatic storage? Which one is more, adiabatic storage or diabetic storage? Are available?
Sir, diabetic.
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 Diabetic. Good. So, though there is no availability of adiabatic storage, this is advantage type, or this point is advantage or disadvantage?
Uh, disadvantage.
Disadvantage, because we need adiabatic type, but there is no availability of adiabatic type storage. And what are the actually reservoir air we used? What kind of reservoir we used in case of compressed air energy storage system? What are the reservoirs?
Salt dome type. Abundant mines and salt domes.
Salt domes and abandoned mines, okay, used as the reservoir in case of compressed air energy storage system. Okay. And how the salt dome is created, do you know?
No, sir. No, sir.
The salt dome are preferred uh, with respect to abandoned mines, because the wall of the salt dam, there is no, basically in case of salt dome there is no crack on the wall of the salt dome, so we can say the heat loss is less in salt dome. So we prefer salt dome with respect to abandoned mine. And how we create the reservoir or cavern, salt cavern? First we uh, flow water in the salt dome and take out the water by a pump, so that there is free space is available on salt dome. After that, the empty salt dome or cavern used as reservoir of compressed air energy storage system, and we prefer salt cavern as a reservoir of compressed air energy storage system. We prefer more because heat loss in salt cavern is less than the abandoned mine. Okay, it is clear to you, Avinash, why we prefer salt cavern?
Sir, it has low heat loss
It has low heat
as
loss. Good.
compared to. Yes.
Now we take the attendance. You are present now. Avinash,
Present, sir.
Rahul,
Yes, sir.
Ritesh,
Yes, sir.
Pooja. Pooja, are you
Yes,
there?
sir.
Deepak,
Yes, sir.
Rishika, Rishika, are you there? Priti Kumari,
Present, sir.
Akshay Kumar,
Yes, sir.
Anjali,
Present, sir.
Anjali Rani and Anjali Kumari. Both are present.
Yes, sir. Yes, sir.
Irfan, Irfan,
Yes, sir.
Swati,
Yes, sir.
Vijay,
Yes, sir.
Sambar.
Yes, sir.
Okay. That's all for today. Okay. You may leave now.
Thank you, sir.
Okay. Okay. Thank
Thank
you.
you, sir. Thank you, sir.